Hi everyone, and welcome to Pre-Calculus Chapter 7, Lesson 1, Trigonometric Identities. In this lesson, we're looking at how to simplify expressions that contain trig functions, and then we're also looking at how to prove trig identities. But first, let's talk about a few strategies and a few formulas. You'll notice at the right side of my screen, I have some strategies that you're allowed to use in any situation, and these are just suggestions. So you can use the identities to replace an expression. For example, let's say I have secant squared in my formula. I can replace secant squared with tangent squared plus 1. I'm allowed to do that anytime I want. If I have cosecant, I'm always allowed to replace it with 1 over sine. So I'm always allowed to do these replacements. The second strategy is to put everything in terms of sine and cosine. You're always allowed to do this. However, sometimes it makes your life a little harder. So think carefully, try something. If it doesn't work, erase it and try again. Another strategy is to get common denominators and add some fractions. So if you see fractions happening with addition or even subtraction, you're allowed to do this. Another strategy is to separate fractions into adding or subtracting of fractions. So that means if I have like sine x plus cosine x over cosine x, I can separate that into sine x over cosine plus cosine over cosine. Okay, and that would look like this. I have this fraction where I have addition happening in the top, so I'm allowed to separate it out into two separate fractions. Now, if this had been subtraction, I would also be allowed to do it, but it only works if it's the numerator of the denominator that has the addition or subtraction. Okay, the next strategy is to factor, so I can use quadratic factoring on some of these, or factoring by GCF. Another strategy is to multiply by a fraction that is equal to 1. So those are my strategies, and you'll see me use those throughout, and I'll refer back to that. And then I also put down some formulas, and hopefully these are familiar by now. These are formulas that you've probably seen in your past few chapters: reciprocal identities formulas, Pythagorean identities formulas, and the even-odd identities formulas. There are a few other formulas that come up, like the cofunction formulas and things like that, but these are the main three categories of formulas that you would probably want to be using. So now that I've introduced our strategies and formulas, let's take a look at some examples of what we need to do. So my first example says to simplify the expression cosine t plus tangent t times sine t. Now, just a reminder, these t's are the variables that are attached to the cosine, the tangent, and the sine. They cannot be separated from them. So when you start a question like this, take a look at the strategies and start looking through them and decide which strategy you want to use. I recommend pausing the video, picking a strategy, and then hitting play to see if you're right. So decide on a strategy. In my case, I think get everything in terms of sine and cosine might help me. So I notice that tangent is sine over cosine. So I'm going to replace tangent with sine over cosine, and that's this reciprocal identity right here. So that's my first step. So I used this identity, and I just replaced tangent with that. Now I am allowed to simplify this. So I can do my fraction multiplication. This would be sine t over 1, and I can multiply sine t over cosine times sine t over 1. And you'll notice a lot of fraction operations coming up in this, so be sure to be aware of how fractions work. So my simplified formula looks like this. And I know it doesn't seem very simplified right now, but we are almost there. So now I'm going to look back at my strategies and try to pick another one that might help me. And I notice that I do have a fraction here with some addition happening. So I think I'm going to do this strategy: get common denominators and add fractions. In order to do that, this cosine t needs to be multiplied by a fraction that is equal to 1. So I'm going to multiply by cosine over cosine on that 1. So here's my multiplication. Cosine t over cosine t times cosine t over 1. And I just added the over 1 here to do my fraction multiplication. And it comes out to cosine squared t over cosine plus sine squared t over cosine. So now I can add these two fractions together. That becomes cosine squared t plus sine squared t over cosine t. Now I need to figure out some of my last steps. I'm really almost there. And my advice is anytime you see your trig functions squared, think about the Pythagorean identities and see if there's one that might help. In this particular case, this very first Pythagorean identity will work. So I'm going to substitute a 1 where I see cosine squared t plus sine squared t. So I'm going to do that, and then I will be almost there. That produced 1 over cosine t, and for my reciprocal identities, I know that 1 over cosine t is secant t. So my final answer for this one is just secant t. Okay, so the only answer I need to write is secant t. So this expression simplifies to just secant t, and that's all I need. Okay, so the next example I have is this one. It says to simplify the expression sine theta over cosine theta plus cosine theta over 1 plus sine theta. Now, I know it seems hard, and they do get easier with practice, so I recommend pausing the video, trying it on your own, try and pick a strategy, and then hit play and see if you're right. In just a minute, I'm going to show all of these steps for this one and what it simplifies to. So what I did, I got common denominators because I saw fractions with adding. So I decided to get common denominators. This first fraction, I'm going to multiply by 1 plus sine over 1 plus sine. And I'm allowed to do that because this would equal to 1. And the second fraction, I'm going to multiply by cosine over cosine. So I'm allowed to do that because cosine over cosine is equal to 1. Now I'm just going to simplify that. Okay, I can do sine theta times 1 plus sine theta plus cosine squared theta all over this denominator. Now, I'm not multiplying that denominator yet. I can. But later on, it might reduce. So I want to wait to do that till the very end. In the numerator, I can multiply the sine theta into the 1 plus sine theta to get sine theta plus sine squared theta plus cosine squared theta all over this denominator. Then I recognized sine squared plus cosine squared as a Pythagorean identity. So I replaced it with 1. So I had sine theta plus 1 on the top. Last, I reduced this to get 1 over cosine theta, and 1 over cosine is equal to secant. And I know secant was the answer we got in our last example, and they will not always all come out to secant. Sometimes it's just 1, sometimes it's 0. They don't always come out to secant. These two just happened to do that. So that's it for this video. Our next video is about proving trig identities. So make sure to watch that one as well.